Hello and welcome to section 6.7, where we're going to talk a little bit about nucleophiles and electrophiles. So where we'll start here is in previous discussion we had in chapter 3 about Lewis acids and Lewis bases. So if you remember, in chapter 3 we had some kind of example like this, where we had some nitrogen with a lone pair, and this boron had maybe some fluorides on it, something like that. And the nitrogen lone pair attack the boron because the boron has an available p orbital here that's empty. And so since it attacked the boron, we ended up making something like this. Where the nitrogen has a plus and the boron has a minus. Now, the Lewis bases are electron pair donors, and the Lewis acids are electron pair acceptors. So looking at these, it's easy to say, you know, this is a Lewis acid, this is a Lewis base. Oh, sorry. Lewis base here, Lewis acid here. And then to see that the resulting complex is fully charged. In this section, we're going to talk about electrophiles and nucleophiles. So let's start with nucleophiles. Nucleophiles are atoms or molecules that have high electron density, like the amine in the previous example, that attack other molecules. And they are also Lewis bases. So in order to have high electron density, typically you need, let's say for instance, molecule like this ethoxide. Normally it's ethanol if it's protonated, but if it's not protonated and it has a negative charge, it's called ethoxide. So this ethoxide has high electron density on the oxygen, right? And if it was near something like boron, a strong electrophile, then it could attack the boron, right? Or something we saw in chapter 3, another type of nucleophile reaction is if you had maybe ethanol, you know, its cousin here. The lone pair could also attack that proton. And the electrons could go back. It's also an acid-base reaction, but it's technically also a nucleophilic reaction since the electrons are attacking an atom, an electrophilic atom, which is the hydrogen. One last example. We could also be looking at maybe some alkyl halide, like a chloride, onto some carbon. So here, the chloride, if you remember from chapter 1 where we talked about dipoles, the chloride is more electronegative, and it's going to be pulling the electron density away from the carbon, making a dipole that goes this way, where the carbon now has a partial positive charge, and the chlorine has a partial negative charge. What this means is that the lone pair on the oxygen can come behind the chloride, attack the carbon, and push off the chlorine. And here, the methyl chloride here, the chloro CH3 molecule, it acts as an electrophile. And electrophiles, in short, are just atoms or molecules with low electron density that get attacked. By other molecules. As we just saw a second ago. Another example of a nucleophile-electrophile reaction is if, say, you have some double bond, and you also have another electrophile like let's do a different color. This iodoethane, it's an ethyl substituent, or it's an iodo substituent on an ethyl group. And here, once again, there's a dipole that runs from that carbon attached to the iodide towards the iodine atom, which means there's a partial negative on the iodine and a partial positive on that carbon. And the partial positive is enough that the lone pair, not lone pair, sorry, but the p orbitals that make up the double bond actually make substantial electron density on one side of this double bond. And so because of that, the double bond acts as a nucleophile. To attack the carbon that has a partial positive charge and push out that iodide. And what we're left with when we do this reaction is some carbon here we won't worry about what we're left with. We'll cover that in another chapter. But this is the basics of nucleophiles and electrophiles. This has been section 6.7.